there was a little bit of a eureka moment actually, because I started on my program right from the north and worked southwards. So I started
From Conchi south.
Well, I was actually started even further north than that at Arica,
Up by the border.
right on the Peruvian border.
Yeah.
And I was taking the flight back to Santiago from Arica after several months up there, and of course we flew due south, and the sun was setting as it normally does in the west, and all the volcanoes were in beautiful silhouette. So we flew southwards, and I could see this line of volcanoes, of course, above the active subduction zone. And in the middle of all these things, because of the elevation of the aeroplane, I could see these big zones of alteration. I thought, well, gee, those have got to be the tops of porphyry copper deposits, just sitting there looking out of the window. So then we factored into the program. We climbed a lot of these things to have a look at what the alteration was. Of course, we now know this alteration is advanced argillic alteration, steam heated very high up in the edifices, and the slightly more eroded ones that were obviously more eroded, they'd still got some of the outer depositional edifice preserved, but all the top had been chopped by erosion. We were going down into quartz alunite facies there, and in what we now call lithocaps. So that's where all that started. So there were two aspects to it really. One was that it was relating all this, the volcanoes and the porphyry copper deposits, to subduction of oceanic lithosphere below the arcs, and the other was the linkage between volcanism and the porphyry copper deposits and the tops of these systems being preserved in these edifices. Of course, since then, I mean, that was very, very crude. We now know that a lot of deposits probably don't have very much related volcanism at all, but some do.
And then, when then did you start incorporating ideas of rates of uplift and erosion as part of the model?
Oh, that was quite a lot later, really. I think that was probably by the 90s.
Okay.
Because back then, you see, the Andes was considered by most people to be an extensional mountain belt. So all the compressive tectonism that we currently know about was never recognised because all the faults were high angle, and for some reason they'd always been considered by the tectonics brigade as normal faults or strike slip faults.
I expect there were probably some Anaconda people that were aware of low angle, because you think of, say, the Potrerillos porphyry.
Yeah, but that's a pretty special case. See, there's not very much low angle faulting of any importance in Chile. All the big movement is on high angle reverse structures.
And strike slip.
Yeah, and yeah, with a component of strike slip to them. But those ideas, the structural geologists weren't starting to generate those ideas until really about the mid-1990s, something like that. And that's when, you know, the idea that just looking empirically around the globe, it was obvious that the large high-grade and high hypogene grade, large-sized deposits were linked to these contractional segments of mountain belts.